Okay, the chain rule is the method of differentiating a function that's a composite function. So let's take a quick little review of what a composite function is. A composite function is a function inside of another function. So it typically is notated as f of g of x, where g of x is the inside function and f of x is the outside function. And what this means is that x goes into, let's say, the g function, and it is changed. Its output becomes g of x. That becomes the input into the f function. And so what comes out is once again changed as f of g of x. So if we're trying to calculate the derivative, and you remember the derivative is the rate of change or the slope, then we have to account for not only the change that's going on as a result of f, but we also have to take into account the rate or the change occurring because of the effect of the g function. So let's take an example of a composite function, and then we'll kind of get into the derivative. So an example of a composite function could be the sine of x squared. So in other words, we would put a value in for x, and it would be squared before sine ever acted upon it. Another one could be e to the sine of x. So I could put a value in for x, then I would take the sine of that x before e ever acted upon it. So it's really important that you're comfortable with what composite functions are so that you know when to use the chain rule. So let's take a couple examples, or let me tell you what the chain rule is, and then we'll look at a couple of examples. Say I'm given a function f of g of x, and I want to take the derivative of that. Well, I'm going to take the derivative of the outside function without changing the inside function. So in other words, I'll take f prime, but g of x stays the same, and then I will multiply by the derivative of g of x. I think an example really helps. So let's say that I'm taking the derivative of one of those examples I looked at of a composite function, and say I had the sine, and I'm going to use a little color here to make things clear, the sine of x squared. Well, the chain rule tells me to first take the derivative of the outside function, which in this case is sine, because remember, sine doesn't operate on x until it becomes x squared. So my outside function is sine. The derivative of that, of course, is cosine. So I get cosine of x squared, because in the chain rule, g of x doesn't change. But then I multiply by the derivative of the inside function, so times 2x. That gives me a final answer of 2x cosine x squared. Let's try another one. Say we were taking the derivative of e to the sine x. Well, once again, the outside function, we take the derivative of the outside function, but in this case, that's e, and it doesn't change. So we're left with e to the sine x. Now we multiply by the derivative of the inside function, which is cosine of x. All right, as you can see, the chain rule is not difficult in itself, but it can get really complicated. Let's take a look at one very complicated example, and then we'll let you try some easier ones, and that will increase in difficulty for homework. Okay, let's look at this frightening thing. Here you can see that we have actually a function inside another function. So 2 to the x is one function, sine is the function that 2 to the x is in, and then both of them are in the square root function. So the first thing I do whenever I get a square root is I rewrite it. So I'm going to say that this is equal to the derivative of sine to the 2 to the x, all of which is raised to the 1/2 power. Now it just makes it easier for me to recognize to use the power rule. Alright, so let's take the derivative. As, of course, we're going to take the outside function first and work our way in. So I'm going to use the power rule and take 1/2. Now, at this point, you don't change the inside functions. So sine of 2 to the x stays the same way. Sine of 2 to the x, and then the whole thing is now raised to the negative 1/2. Now we're going to multiply by the derivative of what had been inside the square root. So the derivative of sine to the 2x is cosine of 2 to the x. And now we multiply by the derivative of the innermost function, which is 2 to the x. So we multiply by the natural log of 2 times 2 to the x. Okay, that's an example of how much of a handful the chain rule can get. I'll give you some that are worse, but not right now. Okay, thanks very much for watching. I hope this helps.